Math 102, example 3.4.2. So let's do another example where we have to find all of the zeros of a polynomial. Now this is degree 4, so that means I've got 4 zeros to look for. So again, to get my possibilities, P is what multiplies to the constant term, which here is 2, and Q, that's what multiplies to the leading coefficient, which here is 6. So again, I put all the P's over all the Q's. So I'll put 1 and 2 over 1. Let's put 1 and 2 over 2. And again, I am going to get some repeats here. Let's put 1 and 2 over 3. Let's put 1 and 2 over 6. And there's another repeat. So those are my list of possible rational zeros. Now again, that's still a fair number of zeros to pick from, so let's get a graph. You can't see my whole function there because I've run out of room, but let's hit our graph button and see what it looks like. Now, if you look at that, I look like I have a zero at approximately 1.5. If we look in our list of possible rational zeros, though, none of those numbers are approximately 1/2. So something strange is going on here. I maybe don't quite know what, but something weird is going on. Now, both plus or minus 1 and plus or minus 2, those aren't going to work. So I'm pretty much stuck with picking fractions. I'm going to start with the least painful of my fractions, so let's pick 1/2 and see what we get. So 6 times 1/2 is 3, plus -5 is -2, times 1/2 is -1, plus -11 is -12, times 1/2 is -6, plus 10 is 4, times 1/2 is 2, and I get a remainder of 0. So yay, looks like 1/2 does work. Let's look at that quotient though. That is not a quadratic. That's a cubic. So it is correct to say that if I set that equal to 0 and solve, I would get my remaining zeros. However, we don't really know how to solve a cubic. We want to get a quadratic because we know how to solve a quadratic. So that means I'm going to look at my list of numbers again, and let's try guessing a second time. Again, checking my graph, it does look like I've got 2 zeros somewhere there between 0 and 1. So I guessed 1/2. Let's try 2/3. Now when I guess, I'm going to use the quotient that I just got instead of my original polynomial. So I've got 6, -2, -12, and 4. So here I get 4, plus -2 is 2. Now, as I multiply here, I will get fractions. It is possible to have polynomials with fraction coefficients. However, the problems that we will see in this class, if that happens, you may safely assume that we are not going to get a 0 remainder there. So that means I guessed wrong. That's okay. That's going to happen sometimes. So okay, 2/3 didn't work. What about 1/3? Let's put that over here. And again, I'm using the quotient that I got with my previous 0. So let's see what I get this time. That's going to give me a 2, which adds to 0. 0 times anything is 0. And then -12 times 1/3 is -4. So I do get the remainder of 0 that I was hoping to get. That's my little remainder there. So again, particularly with fractions, if you guess a bad one first, that's okay. That happens. Let's just try another one. So I've got 2 zeros. Again, I've got 4 total. But let's then look at that quotient. That is 6x squared minus 12. That middle term is 0, so I don't have to write it down. Now again, you can use the quadratic formula here, but I'm going to use the square root property. So let's move the 12 to the other side. Let's divide by 6. And then taking the square root, remember I get both plus and minus. Now the square root of 2 is approximately 1.4. Let's pull up my calculator again. we said we had a 0 at approximately 1.5. That is that square root of 2. However, the square root of 2 is not rational. And because it's not rational, it did not show up in my list of possible zeros here. It's not rational. What that means, you have to find the rational zeros first and get a quadratic, because the only way I can get these non-rational zeros is by solving that quadratic. So again, the method we have here, you have to first have the easy zeros, and only then can I get the not so nice zeros. And those are the 4 zeros that we found.